Now, when we left yesterday, at the end, I got this put up on the board for you to try out, and I said that we would work it today. So we're going to start off by working this question. How many formula units are in 2.85 moles of potassium chloride? So if I go back, and my flux capacitor is kind of naked, so to speak, because I don't have what I told you to put right there. I don't have the conversions here and here, like it's on yours. But nonetheless, where am I at? Where am I starting? Where do I want to put my little hand here? I'm on the mole, right? So I put my little hand on the mole, and what do I want to convert it to? Representative particles, because it is what? A formula unit. Now let's go on, let's expand with that. What does a formula unit tell you? Okay, it's telling you the label is formula units. What does that mean? How do we know something is a formula unit? Thank you, Connor. Now, don't everybody scream it out at once. Okay? It is ionically bonded. So, I am right here. I am following down the green line to get to representative particles. So when I do so, I know that I come back and 2.85 mole of potassium chlorate. I make my conversion box. What do I want to cancel? Moles, right? So I'm going to put that on the bottom, which if you follow your flux capacitor, it'll say this also. 1 mole of KClO3, and on the top is Avogadro's number, right? Isn't that the conversion factor that follows that green arrow from mole down to representative particle? Do I get my labels to cancel? Well, I get mole here to cancel. I get a mole here to cancel. So, my new label is going to be formula units of KClO3. Is that what I want to define? Yeah. Okay. So all I need to do is, in my calculator, I plug in 2.85, and I multiply that by Avogadro's number, and I come up with a value. How many significant digits? I have 3 significant digits, or significant figures. So I have 1.72 times 10 to the 24th. And when I'm writing these out, when I'm done, I put a big box around my answer, so that when Mr. Braun is grading these, he knows exactly where my answer is. We okay? Because we're going to get a little bit tougher now. So we're good with this? Now, sample number 6, I'm going to give you a second to write it down. Okay, hydrogen atoms are in 0.944 moles of ammonia. Now, here's the rub, folks. I am trying to find hydrogen atoms, and I'm given ammonia. Now, what is ammonia? I told you that's one of the things you need to memorize. That is ammonium ion. What is ammonia? NH3. So ammonia is NH3. So what I'm dealing with here is what I call apples to oranges. I have an apple here in ammonia. I have an orange in hydrogen atoms. They're not the same, are they? So I cannot convert from moles of ammonia to atoms of hydrogen. I have to have a middleman. Well, ammonia is a covalent bond, so what I'm going to do, if I look at my flux capacitor, I'm going to convert from moles to representative particles, which is going to be molecules of ammonia. So I'm going to convert this from molecules, or from moles to molecules of ammonia. After I get done with that, I'm going to convert it to atoms of hydrogen. If I were you, I would draw that picture right there. Okay? If I were you, I would draw that picture right there. So I'm going to stop my recording. So as I look at this, and I put my little hand up here on mole, and I come down to representative particle, that's one step. As I come over here to atoms of hydrogen, that's two steps. So I have to have two calculations in order to do this problem. Can you understand why I need two calculations? It's because when I come back here, my given ammonia was different than what I'm trying to find. So what I'm going to do to start with is I'm going to convert moles of ammonia into molecules of ammonia. So 0.944 mole of ammonia. I'll do my conversion box just like I have been doing. And if I follow my flux capacitor right, it's going to tell me that 1 mole of ammonia is Avogadro's number of molecules of ammonia. Now, just like before, do I get my cancellation to occur? Yes, I do. So now I've converted this into molecules of ammonia. So go ahead and do your math on that. Once I've done the math, I come up with the number 5.684768 times 10 to the 23rd molecules of ammonia. Would you agree with that? Now, that whole big number, I leave in my calculator. Okay? I don't want to round this now. I want to round this on final answer. So don't round it yet. Leave that number in your calculator. So I'm going to take times 10 to the 23rd. I'm going to take that number, and that is molecules of NH3, right? That's the answer I got right here. So I'm going to bring that over to here. And I'm going to convert this into hydrogen atoms. So once again, I'm going to convert using a conversion box. So I put my conversion box in there. What do I want to cancel? I want molecules of ammonia to cancel, right? So I'm going to put that on the bottom. Agreed? So, molecules of ammonia. Now, here's our conversion factor. If I have one molecule of ammonia, how many hydrogen atoms do I have? How many? 3. 3 atoms of hydrogen. My molecules cancel, right? So what is my answer going to be labeled? Atoms of H, hydrogen, right? Can I do my math? Take that number that we just got, that 5.684768 times 10 to the 23rd, and all I simply do is what? Multiply it by 3. Now I'm going to sig fig it too. Now I'm going to sig fig it. How many sig figs? 3 sig figs. So my number is 1.71 times 10 to the 24. A little bit tougher, but the recognition, it's a little bit tougher, but the recognition comes right up here, where we say, okay, hydrogen atoms, and I'm given ammonia. Now, I'll give you a second to write this one down. How many atoms of oxygen are in 0.515 moles of strontium nitrate? Now once again, I'm dealing with strontium nitrate, and I want atoms of oxygen, correct? So can I go from directly strontium nitrate to atoms of oxygen? No. What's my middleman gonna be? Moles to what? Close. Michael, you're close. You're close. Is this covalently bonded? Our middleman's gonna be formula units, because that's ionic. So, I'm gonna first convert to formula units. So 0.515 mole of strontium nitrate. Strontium is a 2+. Sound right? Strontium is a 2+. So it's going to be SrNO3 2. Set up my conversion box. I know that 1 mole of strontium nitrate has Avogadro's number formula units of strontium nitrate. I come back to check. Do I get a label to cancel? Yes, I do. So my value that it equals, I'm going to bring all the way over here, folks. The value it equals, I'm going to bring all the way over there. So 0.0, check, 0.515. I multiply that by Avogadro's number of formula units, and that gives me a number that looks like this. 3.10, 133 times 10 to the 23rd. What's my label on that? Formula units of strontium nitrate. Now I've got to convert this to what? Atoms of oxygen, right? So, I have another conversion box. What goes on the bottom? How many? Formula units go on the bottom. How many formula units? Look at our last example. What did we do? 1, right? So 1 formula unit of strontium nitrate has how many oxygen atoms? 6, right? Do you see where we got 6? 6? See how we got 6? We're all okay with that? So I take my value. Do I get a cancellation? I should get a unit to cancel. So I get formula units of strontium nitrate to cancel. What is my label going to be? Atoms of oxygen. So I take my value that I just got for strontium nitrate in formula units, and I multiply it by 6. And that gives me, with 3 significant figures, 1.86 times 10 to the 24th. Atoms of oxygen is my label. Yeah, Carly? Because I am rounding it to 3 significant figures. Okay? If I would have 1.861, that would be 4 sig figs. I only need 3 significant figures. What do you think? We okay? Now let me see my next example. On this one, okay, I'm going to walk you through this one, and then we're going to, and I'm going to let you go, all right? Now, I'm going to walk you through it and let you go. So write down this example. Okay, I'm going to walk you through this one, set up, and then I'm going to let you work it. How many moles of oxygen are in 2.21 times 10 to the 70th formula units of copper 2 oxalate? Now, what you should see, your mental thoughts should be, I have copper 1 oxalate, and I want to get what? moles of oxygen. Can I go directly from copper 1 oxalate to moles of oxygen? No, it's apples to oranges again. Apples to oranges. I cannot do that. So, when I come back to my flux capacitor, I have to, before I can start, I need my rep particles to be in atoms of oxygen, right? So the very first thing I need to do is I need to take my formula units and convert those to atoms of oxygen. Once I have converted from atoms of oxygen, can I follow to moles of oxygen? Absolutely. So this is a two-parter. The first thing you do is you convert it from formula units to atoms of oxygen. Once I have atoms of oxygen, I can go straight to moles of oxygen. Okay? I want you to do that right now, and I'm going to be walking around. If you have a question, raise your hand and ask.